to all. Myself Dr. Nilesh Kumar Gupta. I am working as a professor in Department of ECE at Ajay Kumar Garg Engineering College, Ghaziabad. So, today I will deliver a lecture for a subject of Information Theory and Coding. Its AKTU code is KEC 075 and today's my lecture title is Source Coding Part 1. So, now we move on coding part. After the analyzing of information in information theory in terms of entropy, mutual information, etc., we come on coding part, okay, at the source side where we have to encode our information, okay, or we call source coding. We have to code our information in terms of coded form, digital form in terms of 1001, that is source coding. So, now I will start in this lecture source coding, some concept of source coding, what are the main highlights that I will tell you under the source coding, that I will tell you in this lecture. Okay. So, let us recall in last lecture what I told you. I told you or I summarized or I concluded about the information theory concept, basic concept, that the information, entropy, etc. So, last time I told you about the inequalities available in information theory in terms of some theorem like Jensen's, log sum, data processing, Fano's inequality and so on. So, these inequalities generally gave the non-equal comparison between the two mass functions, okay, and these are very important in information theory study also. And as per our requirement, we can refer these inequalities that I told in my last lecture. Then entropy concept and so on. So, just we finish the first part of digital communication system. What is the information? How you analyze our information in terms of entropies, mutual information and so on for any binary channel. Okay. Now, we will move towards the coding part, source coding part. After the information you have to need what? Encode that information at the source side. That is why we are calling what? Source coding. So, these are the main highlights source coding. So, there are so many number of source binary codes by which we perform the source coding for digital communication system, like prefix coding. Some codes are there, prefix code, instantaneous codes, uniquely decodable codes and so on. So, some prefix codes and codings we prefer here. Okay. Then their illustration, how we illustrate or represent those prefix code, and then we implement their prefix coding in the source coding. Now, there is some criteria and inequality we can say, that is called Kraft-Macmillan inequality for verifying the source coding for particular system. So, in Kraft-Macmillan inequality we can see here how we apply the Kraft-Macmillan inequality in the source coding. So, these are the some highlights that I will tell you under the source coding. Okay. Now, source coding theorem, if we are using the number of source code and we are coded those information in terms of binary digits. Okay. So, some source coding theorem or some parameters and characteristics that we decided, okay, under this, that we see under the source coding theorem. Then average code word length. अब कोड तो कोई डिज़ाइन कर लिया आपने, किसी को कोडिंग कर दी 00010 10111, तो अब इसकी एवरेज लेंथ कितने, हम हमेशा चाहेंगे कि इफ को कोड हम जो करें उसकी लेंथ क्या हो, कम से कम, द लेंथ शुड बी मिनिमम, देन वी कैन ऑब्टेन द ऑप्टिमल एफिशिएंसी. देन आफ्टर दैट व्हाट, एफिशिएंसी ऑफ द सोर्स एनकोडर. तो जो भी सोर्स कोडिंग हम चाहेंगे, हम ये चाहेंगे देयर लेंथ शुड बी मिनिमम, एंड इफ द लेंथ शुड बी मिनिमम देन देयर एफिशिएंसी विल बी हाई. हमारा मकसद क्या है, व्हाट इज आवर मोटिव, आवर मोटिव इज व्हाट, टू गेट द बेस्ट पॉसिबल रिजल्ट्स और टू गेट द ऑप्टिमल रिजल्ट्स. ऑप्टिमल मीन्स व्हाट, we want to improve, we want to get higher efficiency also from the source or channel coding. Now, the most important coding, there are so many codings are available for source coding, but they are this is the most important coding, that is called Huffman coding. So, also under the source coding I will tell you about the Huffman encoding algorithm. क्या होती है, हाउ वी अप्लाई इम्प्लीमेंट द हफमैन कोडिंग. देन एग्जाम्पल्स ऑफ हफमैन कोडिंग, इन केस ऑफ टेकिंग द सिम्बल्स 2, 3, 4, हाउ वी implement the Huffman coding as per the their defined procedure. Then variance of average code word length, how it varies as per the number of symbols. Okay. Then efficiency of Huffman encoder. Okay. So, Huffman coding is the most important and most widely used source coding method, okay, by which you can encode easily your information, okay, and you will get the optimum results also. Okay. That is why we are using the this Huffman coding generally for the source coding. Now, the some theoretical and some theorems are there under which our asymptotic equipartition property is there. In information theory, the analog of the law of large numbers is the AEP. AEP means what? Asymptotic equipartition property. It is a direct consequences of the weak law of large numbers. The law of large numbers states that for independent identically distributed random variables, मतलब IID means independent identically distributed random variable. So, some random variables also we are defining, we are considering, we are referring here in terms of IID, those are independent identically distributed. So, these IID terms we are referring under the source coding, okay, or also I will tell you in terms of data compression, because in source coding data compression is also there, okay. That is the main part and main function of source coding. So, as per the this what we can write 1 upon n, okay, summation from I 1 to n x I is close to its expected value E of x for large value of n. So, this says by the AEP, asymptotic equipartition property, AEP. Okay. So, that is for the IID random variables and its consequences or its result in terms of you will get data compression under the source coding. Okay. That also I will tell you the concept. Now, what is the AEP theorem, that I will tell you in by this PPT. So, AEP means what? If x1, x2 up to the xn are IID, IID means what? अभी बताया मैंने आप लोगों को, independent identically distributed random variable belongs to P of x, then 1 upon n log of, इसकी information कैसे देते हैं हम, किसी भी information देते हैं log of 1 upon px. So, 1 upon n, यहाँ लिखा था ना आपने पिछली बार last this. So, how you will get log of 1 upon p x1 x2 up to the xn tends to h of x in probability. अब मान लो इसका प्रूफ हमको करना है. the function of independent random variables are also independent random variables. Thus, since xi are the IID, identically independent, identically distributed random variables, so are log of Pxi. Okay. Hence, by the weak law of large numbers, this is some theoretical concept, but its mathematical consequences you will get in terms of data compression. So, it will be minus ka 1 upon n log of 1 upon Px 1 x 2 up to the xn is equal to minus ka 1 upon I 1 to n log of Pxi. Okay. So, you can write this here, no minus, it will be plus will be there. If you put this in terms of this log m by n, it means log m minus log n. So, it will be in terms of minus ka 1 upon n I 1 to n log of p x I. Now, we can write this minus e log of p x in terms of probability and it will be equal to h of x. h of x क्या होता था हमारा p x into log of p x, which proves the theorem. हम यही चाह रहे थे कि ये जो टर्म है हमारा, it will be converted in terms of entropy of the random variable x. मान लो x हमारा एक सोर्स है, तो h of x is what? It is the entropy of that source or system. So, it tends or it will be equivalent to entropy of the system, that represent by this AEP theorem. It means asymptotic equipartition property. Now, some terms also will be there like typical sets. Typical sets क्या होते हैं? Some mathematical lemmas under the AEP, typical sets and so on also are available, but the concept I am trying to explain. Okay. What? Like for example, if we take an example, if we buys a coin, now we are trying for coming tails number of times. मान लो हम चाह रहे हैं फॉर कमिंग द टेल्स 5 एल बाई के 5 इट्स हम व्हाट बाइस अ कॉइन वी 5 टाइम्स वी फॉर कमिंग द टेल्स. ओके, और 5 बार लगातार टेल्स आ जाए. इन 5 outcomes, continuously 5 tails, for getting the 5 tails, okay, you are determining the probability. So, probability of 5 tails or probability of 4 tails and 1 head, or in this way, okay, you will get. So, typical sets क्या है? It is what if you are selected some points, if you are getting the outcomes number of times, but you are selected the some points, okay, and you are working for that selected points. So, those selected points in terms of h or entropy are called typical sets. So, इसको बोलते हैं हम typical sets. पूरे ना लेके हम कम ले लें. अब हमें ये भी पता है फॉर बाइनरी सिस्टम में बोले हम h ऑफ p के मामले में कि एंट्रोपी 0.5 की ज़्यादा होगी 0.8 से और 0.8 की ज़्यादा होगी 1 से 100%, है ना. जैसे इस एग्जांपल देखें 5 टेल की प्रोबेबिलिटी आने की प्रोबेबिलिटी कम होगी 4 टेल. 5 लगातार कंजुगेट मतलब कंटिन्यूसली टेल्स आना, इट विल बी डिफिकल्ट टू गेट द कंटिन्यूसली 4 टाइम्स टेल कमिंग. Similarly here. So, if you are selecting some points, selected the or setting the some parameters, okay, some selected points, then typical sets terminology will come. Okay. So, in this way you can understand what is the meaning of typical sets. Now, all sequences in typical sets is having almost equal probability. Okay. And we can say it is almost equal to n into h of p, and this is called AEP concept. ये मैं क्यों बता रहा था इतना? I am telling this all the for explaining you the concept of AEP. Okay. So easily you can understand why we are discussing this one, okay, why we are coming on this. So this is the concept of AEP. Now application, AEP, typical set, क्यों पढ़ रहे हैं हम? So application इसका कहाँ? Data compression. Up to n is equal to 100, we can compress our data, okay, and total sequences यदि tool sequence 100 है हमारी, it means 2 to the power 100 total sequences, and typical sequence कितनी? 100 into HP. So if we analyze it around, it will be 2 to the power 72 to 73, okay. So AEP जो हमने पढ़ा mathematically, because some mathematical theorems or expressions are there, and based upon those mathematical lemmas, theorems and expressions, we can standardize and drive something, okay. And this is the nichode, you can say, the result, final conclusion of AEP in terms of typical set. Why we are doing this, why we are studying this? For getting the data compression in source coding. Source coding में data compression को पाने के लिए. Now he was the Claude Shannon, and you can say कि Claude Shannon played very important role for source coding. शेनन साहब की थ्योरम आगे जो भी आती हैं, सोर्स कोडिंग जो भी, तो all generally contributed by the Shannon. Now consequences of AEP. AEP के consequences क्या है? AEP हम पढ़ रहे हैं, typical set दुनिया भर का. So consequences क्या है? In terms of what? Data compression. So let x1, x2 up to the xn be independent, identically distributed random variables drawn from the probability mass function P of x. So we divide all sequences in x of n into two sets. The typical sets, okay, it is denoted by a epsilon n and its complement form. That also I will show in the figure. So we are having all the sequences here and dividing into the some selected points and its complement point, okay, like in terms of typical sets and its complement form, okay. So this diagram, from this diagram we can understand this one, okay. So this whole your area, it shows the all the elements, okay, that we want to represent here. Some selected points we are taking here, these are called typical sets, 2 to the power n HP that I wrote in last PPTs here, okay. So these are the typical sets and remaining will be the non-typical. सीधी सी बात है, कुछ selected points हैं तो वो typical हैं और remaining will be the its complement or you can say non-typical. So in this diagram we can understand this. And the AEP का मकसद क्या है? What is the objective of AEP? AEP is for source coding through the typical sets, and its application part or the final answer or final consequences will be in terms of application of data compression of our digital information. Why it is required, that also I will tell you. Data compression. अब हम सोर्स कोडिंग करते हैं. सोर्स कोडिंग मतलब यहाँ से इंफॉर्मेशन हमारा आई, नाउ सोर्स एनकोडर इज देयर, तो इट एनकोड्स अवर सोर्स, इंफॉर्मेशन को एनकोड करेगा, ठीक है. मान लो 10 10 10 ऐसे इसने कर दिया, कुछ भी 001 क्या हो. नाउ वी नो we are in electronics and communication engineer, we study digital electronics and so on. If we have to write one letter A, B, C, D, so minimum 4 bits you require. If you want to write data, so 4 into 4, 16 bits minimum you require to encode this word of data. If you want to write one line, so many number of bits you required, okay, to get the encoding our information. So our digital information is so big. इतनी अधिक बड़ी इंफॉर्मेशन, लार्ज इंफॉर्मेशन को आगे ऑक्युपाइड करना, कम्युनिकेट करना, it is not practically feasible. So, we have to compress our data, and we have to compress our data in such a way that no information loss will be there. Okay. So, source coding में encode तो होती है हमारी information, it encodes our information along with the compression of data. It is also necessary. If you are not doing this data compression, so it will not be possible to accumulate, occupy all the data under the source coding. Okay. So, data compression. So, the main application of source coding is what, and what we have to do, that is mandatory, that is data compression. Data compression can be achieved by assigning short description to the most frequent outcomes of the data source and necessary longer description to less frequent outcomes. Okay. So, that is called our data compression. It can be achieved by in this way. Okay. For example, in Morse code सुना होगा आपने, in that we can use in telegraph. Okay. The most frequent symbol represented by a single dot. So, data compression is very important, otherwise this huge data of binary huge data you cannot communicate. So, data compression also you need in term for the information source communicating between the transmitter and receiver. Data compression refers to, मतलब क्या है इसका, डेटा कम्प्रेशन मतलब ऐसा थोड़ा ना करेंगे अपन कुछ भी करें, इन्फॉर्मेशन लॉस हुई तो खराब हो गया, देन देयर विल बी नो वैल्यू ऑफ योर communicating the digital information from one end to another end. We have to compress our data in such a way that no information will be lost. That you have to keep in mind. अब मतलब क्या, data compression refers to the reducing the number of bits. 5 को 2 में कन्वर्ट कर दिया, 4 को 1 में कर दिया. ओके, इस तरह से रिड्यूस नंबर ऑफ बिट्स that need to be transmitted over the communication channel. Data compression means the reduces the number of bits sends. So, इस तरह से reduce करना है कि that will be possible to us to communicate that amount of data properly through the channel from transmitter to receiver. Data compression becomes particularly important when we send data with high size such as audio and video signal. ये दिक्कत कब आती है? Generally also because in case of our audio and video signal, because it occupies a large memory, okay, high size of data. So, this high size of data we cannot communicate simply. So, generally we use the data compression. Without data compression we cannot send our like audio and video signals. It is very important. The goal of data compression is to represent an information source. Our information source कैसी भी हो सकती है. It is like a data file, a speech signal, an image, okay, a video signal and so on, as accurately as possible using the fewest number of bits. Okay. So, this is our objective of data compression. Now, how generally in mathematically whenever we simulate the image and some other signals, so some data compression ratio we can use. Okay. For your information I am telling you, the data compression is defined as the ratio between the uncompressed image and compressed. Okay. Like if we want to compress 10 MB file or data into 2 MB. So, compression ratio will be the 10 upon 2 is equal to 5. So, 5 data compression ratio we need, so that we can compress or we can convert our 10 MB data into the 2 MB data. So, it is very important for us, okay, that you have to keep in your mind. Now, some data compression methods. So, we can classify data compression methods into two categories. First is lossless methods and second will be the lossy methods. Okay. So, data compression method we can divide, okay, into the lossless and lossy methods. It depends upon the our data. Okay. So, in this way some techniques we can use under the data compression for source coding of our information source. So, source coding में source coding ही नहीं होती, along with data compression भी होता है. It is very important, because without data compression you cannot go and you cannot communicate further into the communication system. Now, these are the references, okay, that you can refer for studying the source coding. Okay. So, source coding is very important part of digital communication, or it is the basic of information theory. Whenever you get the information source, now you need that information source in terms of some source coding, okay, along with the data compression and so on. Okay. So, thank you very much.